Alrighty, so a study was conducted to investigate the effectiveness of hypnotism in reducing pain. Results for randomly selected subjects are shown in the table below. A lower score indicates less pain. So each of these are matched together. We have one subject, their before score is first, their after score is second. All right, another subject, before was 6.5, after was 2.4. So what we're going to have to do here is compare the before score to the after score. And we're looking overall, the test we're essentially running here is the average difference. We're going to use this sub-index mu sub d to represent the difference. Our difference is always going to be the first minus the second. In this case, that's before minus after. If it was something like the example I keep throwing out about a left and right eye, we would be doing, left maybe minus right, depending on what's listed first and listed second. The reason this is important is because that's how the calculator does it. So if you want to be able to input your data, how it's listed here, we need to call it the first minus the second, or in this case, before minus after. Okay, I'm writing this out because we're always going to have this null and alternative hypothesis still. And these null and alternative hypotheses are going to be talking about the difference compared to zero. Okay, why compared to zero? Because like what we did before, right back when we talked about means for the first time, if we had this statement, it was the same thing as the subtraction being equal to zero. If I subtracted that mu sub 2 to the other side, this side would zero out, and we would have that difference over there, mu1 minus mu2. Well, that is what our mu sub d is. It's mu1 minus mu2, one of the pieces of data minus the other. So that is why we're comparing to zero, because no matter what that inequality was, it would be that difference, mu sub d, being compared to zero, greater than zero, less than zero, equal to zero. Now, more often than not, our original mu sub d, will be equal to zero, meaning that there was no difference before or after. If it was a case where it's thought that this is the case, all right, we could say it's greater than or equal to or less than or equal to. But, like with the proportions, a lot of the time it is going to be an equals for that H naught. For HA, this can change. Your alternative hypothesis can change depending on what we're trying to show. What we are trying to show here is that the after is lower than the before. We want to show that it does decrease pain. We want to show after is less than before. So does that mean the difference should be greater than zero or the difference should be less than zero? If you have trouble with figuring this out, whether we want mu sub d to be greater than zero or less than zero, I recommend you look at one of the outcomes that looks good, one of these subjects that meets what we're trying to show, and check if their difference is positive or if their difference is negative. So for example, this subject here, subject B, went from a 6.5 before to a 2.4 after. Their difference, we know that they're a good patient, or at least, they're a patient that helps our cause because they decreased overall. So their difference, 6.5 minus 2.4, is equal to 4.1. This is positive, meaning that difference is greater than zero. That's what we're trying to show here. Again, I picked one, I picked that one, I could have picked this one, I could have picked this one, this one, this one, this one, or this one. The only one that actually didn't show what we were trying to show was contestant A or subject A. If I did their subtraction, I would have ended up with a negative 0.2. all right, showing that mu would be less than 0 there. But we didn't, that like they weren't helping our cause. Hey, this is just a little side technique to help you figure out if we're trying to show for our alternative that mu sub d is greater than 0 or it's less than 0. Here, this means that we have less pain after. Here, this was the same pain before and after. All right, and now we run our test. The running of the actual test is very, very similar to our chapter 9. We are going to use different calculators though. We're going to go to those LibreText statistics calculators. We are going to head to 2 means, right? Before we had hypothesis test for a mean, a proportion, and then we had 2 independent samples with data, 2 independent samples with statistics, 2 proportions. Now we are on the matched pairs, right? These are the dependent samples with data. We want the dependent samples. When we enter these, we have to be very careful that we don't make any mistakes. We want the data values with a comma in between, 6.6, comma 6.5, comma, I'm gonna have to keep clicking this, that's okay. I'm gonna be very careful. Hopefully I don't make any mistakes here. 9.0, 10.3. And again, the order does matter because we're gonna have to line up our second row of data in this exact same order. So I've got all of my first row in, hopefully. Let me just double check real quick. 6.6, 6.5, 9.0, 10.3, 11.3, 8.1, 6.3, 11.6. Then we have 6.8, 2.4, 7.4, 8.5, 6.1, 3.4, and 2.0. Oops. Looking really good there. 3.4. All right, 6.8, 2.4, 7.4, 8.5, 8.1. Oh, see? Always double check. 6.1, 3.4, 2.0. 1, 2, 3, 4, 5, 6, 7, 8 subjects. 1, 2, 3, 4, 5, 6, 7, 8 subjects. The values that we fill in are the same like we did in chapter 9. This is for the alternative hypothesis. In our case, we wanted mu sub d, the difference, to be greater than 0. So we're going to click that greater than button. And we were running this at a 5% level of significance. So if we did want to look at that confidence interval down here, we want to make sure to put in that 95% or 0.95. All right, we get a t-score of 3.0359 and a p-value of 0.0095. 0.0095. All right, we were comparing that to our alpha. Our alpha is our level of significance. And again, we ran this at a 5% significance level. So that means alpha is 0.05. Let's go place by place here. 1 after the decimal, zeros. 2 after the decimal, 0 and 5. Alpha is greater than p. So the p is low because it's smaller. If the p is low, the null must go. Our decision here is going to be that we reject the null hypothesis. That's our H naught. All right, the conclusion, this is where we get to tie everything back together. We can say at the 5% level of significance. That's what we ran this test at. the 5% level of significance, there is sufficient evidence. We were able to draw a conclusion. There is sufficient evidence to support and this is where we note what our alternative was, that the difference, the average difference is greater than 0. Now, talking back to what we actually were dealing with here, that doesn't sound all that great. We want to say to support or to conclude that the sensory measurements on average are lower after hypnotism. That's what we were trying to show. We were trying to show that they were lower after hypnotism. So we have sufficient evidence to support that the sensory scores or measurements on average, it's always good to put in the word average somewhere since we are talking about the means here, on average are lower after hypnotism. That's what it meant by the differences being positive, is that they were lower after hypnotism. All right, hopefully you followed along with that. Try a couple on your own in the homework. We are going to do one more example together.